Its howling disciple mythical gods, the number 12 appears often in the telling of our greatest stories about ourselves. And what about distance? Your local town might be measured in meters or other units, but when we talk about measuring our planet, the standards we all use revert back to base 60 units of miles, minutes, or geometrical degrees. Are you noticing the pattern here? We seem to be encountering a lot of 12s and 60s. Are they related? And if so, how? To answer that piece of the puzzle, we must travel roughly 5,000 years back in time to visit the ancient Sumerian culture of Mesopotamia, for here is where our 1260-based math comes from. This counting system, which was invented by the same people who produced the world's first written language, involved counting the knuckles of the 4 long fingers on one hand and then multiplying them by all 5 digits on the other hand. If you do this, you will get a maximum number of 12 knuckles times 5 fingers, which of course totals 60. How these cosmic jumps in language and mathematics occurred so suddenly is open to debate, but it is interesting to note that the ancient Sumerians themselves wrote about being given this information by sky god visitors they called the Anunnaki. Who and what the Anunnaki were is a hotly contested subject, but one thing that cannot be denied is the fact that over 5,000 years ago, a mathematical system was born that incredibly still serves us today. So now that we have our various units of measurement, all based on the Sumerian 1260 counting system, let's jump forward to a few pivotal moments in history and see what other numbers, patterns, and synchronicities appear. In the 6th century BC, on the Greek island of Samos, the famed mathematician Pythagoras led a school of thought that married philosophy, mathematics, music, and of course geometry. And while Pythagoras did not discover advanced geometry, he did apply it in new ways, especially to music. For instance, he noticed that when a tauten string was plucked, it would create a tone. And when that string was divided in half, it would make the same tone only twice as high in pitch. Pythagoras then came up with numerical ratios based on harmonic fifths, and this led to the creation of the musical scale found at the root of most modern music. It is important to note that according to Pythagoras, all musical notes were found by using mathematics, and as such were given number values according to their placement in a kind of master grid. For instance, by using fifths beginning from note number 1, he was eventually guided to note 27. And to find the same note twice as high in pitch, he simply kept doubling it to 54, 108, 216, 432, and so on up the scale. If you've ever heard of Pythagorean tuning, you know that the number 432 is quite important. To Pythagoras himself, it probably wouldn't have stood out more than any other in his numerical grid. But in our quest to find a universal language based on mathematics and frequency, this particular note represents a significant piece of coincidental evidence. You see, many ancient musical instruments, from Tibetan bowls to Native American flutes, happen to produce the same tone, a tone that vibrates at 432 cycles per second. That's compelling. But even more intriguing is the fact that Pythagoras was not calculating vibration cycles to find tone 432. It just happens to be the same number. What's more, for decades, most modern musical instruments were also tuned to this same 4th octave A, with a value of 432 cycles. How could this be? Who chose this particular note as the keystone for instrument tuning? And more importantly, why? Here is where a deeper mystery begins to emerge. And to explore it, we will need to go back to Pythagoras' other passion, geometry. It is not an exaggeration to say that to Pythagoras and his disciples, geometry and math held a key to the nature of all life everywhere, and maybe it does. Let's look at the first 4 geometric shapes, the circle, triangle, square, and pentagon. In each of them are angles of degrees that, when added together, always total a specific number relative to that particular shape. For instance, if we take a triangle, the sum total of all 3 interior angles is always 180. For both the square and circle, it is 360. For a pentagon, it is 540. Now at this moment, let's step back and look at these numbers in a different way, as there seems to be something about them that reaches beyond a simple sum of angles. Did you notice that they happen to be in the same numerical neighborhood as tone 432? What's more, they all add up to 9, just like 432. As an experiment, let's take a look at the numbers found in basic geometric shapes, then apply those numbers as vibration cycles to hear the tones they produce. First, let's listen to what the 180 total